We've explored Earth, walked on the moon, and sent spacecraft to the far reaches of our solar system. But the question is, could humans ever leave our own galaxy, the Milky Way? Or is that journey simply too big for us to even imagine? The Milky Way is our cosmic home. It's a huge spiral-shaped galaxy, filled with over 100 billion stars, countless planets, and massive clouds of gas and dust. Our solar system is tucked away in a small neighborhood called the Orion Arm, about halfway between the galaxy's center and its edge. The entire Milky Way is about 100,000 light-years across. That means if you could travel at the speed of light, which we currently can't, it would still take 100,000 years to cross it from one side to the other. The immense scale of the Milky Way. The Milky Way is our home in space, but it is far bigger than most people imagine. It's a huge spiral-shaped galaxy made up of over 100 billion stars, each with the potential to have its own planets. Our solar system is just one tiny dot in all of this, sitting inside a small arm of the galaxy called the Orion Arm. If we could somehow look at the Milky Way from far away, we would see its swirling spiral arms stretching across an incredible distance. The galaxy is about 100,000 light-years across. A light-year is the distance light travels in 1 year, and light is the fastest thing we know, moving at about 300,000 kilometers per second. So even if we could travel at light speed, which we can't, it would still take 100,000 years just to cross from one side of the Milky Way to the other. That's longer than the entire history of human civilization on Earth. To give you an idea of scale, if the Milky Way were the size of North America, our solar system would be smaller than a coin. Everything we've ever explored, the Moon, Mars, and even the farthest spacecraft, is still inside that tiny coin. When we talk about leaving the Milky Way, we're talking about crossing distances so huge that our current technology is not even close to making it possible. The nearest galaxies, and how far they really are. When we talk about leaving the Milky Way, the next question is, where would we even go? The most famous neighbor of our galaxy is the Andromeda Galaxy. It's a spiral galaxy like ours, and it's the closest large galaxy to us. But close in cosmic terms is still unbelievably far. Andromeda is about 2.5 million light-years away. That means even if we could travel at the speed of light, it would still take us 2.5 million years to get there. Apart from Andromeda, there are also smaller galaxies nearby, called dwarf galaxies. Some of them, like the Large Magellanic Cloud, are only about 160,000 light-years away. That's much closer compared to Andromeda, but still far beyond anything we've ever reached. For comparison, the farthest any human-made object has ever traveled is Voyager 1. After more than 45 years in space, Voyager 1 has only gone about 23 billion kilometers, not even close to leaving the Milky Way or even our solar system. These numbers are so large that our minds struggle to picture them. The truth is, we've barely stepped outside our front door in cosmic terms. Even our fastest spacecraft would take thousands of years just to reach the nearest star beyond the Sun. The idea of crossing the empty space between galaxies is on a completely different level, a level where human lifetimes seem like the blink of an eye. Current technology and its limits. When we think about traveling beyond the Milky Way, the first problem is speed. Our current technology is nowhere near what we would need for such a journey. The fastest spacecraft ever built, the Parker Solar Probe, can travel at about 700,000 kilometers per hour. That's incredibly fast compared to anything on Earth, but in space terms, it's still painfully slow. At that speed, it would take thousands of years just to reach the nearest star and millions of years to leave the galaxy. Voyager 1, which was launched in 1977, is another example. It has been traveling for more than 45 years and is moving at over 61,000 kilometers per hour. Even so, it has only just reached interstellar space, and it's still deep inside the Milky Way. The distance it has covered is tiny compared to the size of our galaxy. The problem isn't only about speed. It's also about energy. Moving a spacecraft, especially a big one carrying humans, to such extreme speeds would require unimaginable amounts of fuel. And the faster you want to go, the more energy you need. On top of that, we would have to solve problems like food, water, air supply, and keeping people healthy for journeys that could last longer than human history itself. Right now, Our technology is perfect for exploring our own solar system and maybe reaching nearby stars in the far future. But when it comes to crossing the space between galaxies, we are still taking our very first baby steps. Theoretical travel methods. Even though our current technology can't take us beyond the Milky Way, scientists and dreamers have imagined ways we might do it in the distant future. One idea is the generation ship. This would be a huge spacecraft where people live, work, and raise families as it slowly travels through space. Generations would be born and die on the ship before it ever reached its destination. It wouldn't be a trip for one crew. It would be a journey for entire communities over centuries or even thousands of years. Another idea is cryogenic sleep, where travelers are frozen for the journey and then awakened when they arrive. This would solve the problem of human lifespans, but freezing and safely reviving people is still far beyond what science can do today. Some of the most exciting concepts come from theoretical physics. A warp drive, for example, wouldn't move a ship faster than light in the usual sense. Instead, it would bend or warp space itself, making distant places much closer. Wormholes are another possibility, tunnels through space-time that could connect two faraway points in an instant. Both of these ideas appear in science fiction, but they're also studied by scientists. The problem is, we don't yet know if they're actually possible, and if they are, they might need huge amounts of energy or technology we haven't even imagined yet. For now, these methods remain just that, ideas. But they remind us that the limits we face today may not be the same limits we face in the future. Cosmic barriers. Even if we had a spaceship that could travel extremely fast, leaving the Milky Way would still be filled with dangers. Space between galaxies might look empty, but it's far from safe. There are clouds of gas, stray asteroids, and tiny dust particles moving at incredible speeds. Hitting even a small piece of space debris could destroy a ship traveling at high velocity. Radiation is another serious problem. Beyond the protection of our galaxy's magnetic field, cosmic rays and high-energy particles would constantly bombard the ship. Over millions of years, this could damage both the spacecraft and the health of anyone inside. We would need powerful shielding, but making it strong enough without making the ship too heavy is a big challenge. There's also the fact that the universe is expanding. Many galaxies are moving away from us faster than the speed of light. This means that no matter how advanced we become, some galaxies will always be out of reach. The longer we wait, the fewer galaxies we'll be able to visit in the future. And then there's the biggest barrier of all, time. A trip across millions of light years could take longer than the human species has existed. Keeping people alive, healthy, and sane for such a journey is a challenge unlike anything we've faced before. These barriers don't make the dream impossible, but they show why it's such a massive leap from where we are today. Why leaving the Milky Way might still be possible someday. Even though the challenges are enormous, history shows that humans have a way of doing things that once seemed impossible. 1,000 years ago, crossing oceans seemed hopeless. A few hundred years ago, flying through the air sounded like a fantasy. Today, we can fly across the planet in hours and send robots to explore other worlds. Technology moves forward faster than most people expect. New discoveries in physics, materials, and energy could one day give us the tools we need for intergalactic travel. A breakthrough in propulsion could allow us to reach speeds we once thought were impossible. A deeper understanding of space-time might make concepts like warp drives or wormholes real. Even small steps, like faster probes or better life support systems, could be the first pieces of a much bigger puzzle. Human curiosity is another reason for hope. We have always been explorers. From caves to continents to the moon, we've never stopped pushing boundaries. The Milky Way is just another frontier, a much bigger one, but still part of our journey. It may take hundreds, thousands, or even millions of years before we can leave our galaxy. But as long as humanity survives and keeps looking to the stars, there's a chance we might one day find a way. The dream beyond the Milky Way. The idea of leaving the Milky Way is both exciting and overwhelming. The distances are almost beyond imagination, the dangers are real, and our current technology is nowhere near ready. But that has never stopped human beings from dreaming. Every great achievement in our history began as an idea that seemed impossible. Right now, our place in the universe is small. We've only explored our own planet, a few nearby worlds, and sent probes to the edge of our solar system. Yet, each step we take teaches us more and brings us closer to the stars. Even if we never see another galaxy with our own eyes, the desire to explore will keep pushing us forward. In the end, leaving the Milky Way might not happen in our lifetime, or even in the lifetime of our children's children. But as long as we keep asking questions, imagining possibilities, and building the tools to reach further, we keep that dream alive. The stars may be far away, but our imagination, that's something that can already travel beyond the edge of the galaxy.